Hello friends, good morning and I welcome you all to a new video lecture series of digital electronics. Okay, so digital electronics, it is a subject of computer science department and the subject code is 204. Okay, so this is the first lecture of our digital electronics. So in this we are going to see the overview of the syllabus of digital electronics. Okay, so as we know the syllabus consists of two sections, section A and section B. So today we are going to see the different units which are covered in the syllabus. Okay, so I welcome you all. I am Saili Rathod. This is the first lecture of the subject. Now, first of all, we will see the examination scheme. Okay. So, in this subject, as we know that the theory examination, it consists of 80 marks and the duration of the theory is 3 hours. Okay. And while studying this subject, we have to spend 4 hours for a week to complete the syllabus, and the class test which is of 20 marks. So 80 marks from theory and class test of 20 marks. Now let's come to the objective and the basics that the student should know. Okay, before studying the syllabus of this semester, the student should know 3 points. Okay, now the first point is basics of analog and digital signals. Means it is expected from all of you students that the basics of the analog and digital signals all of you should know. Then the second point is basic semiconductor devices operation. Means what are the different semiconductor devices, how they are operated and everything. And the third point is basics of Boolean algebra. This is expected from all of you before going forward in this subject. Now the objective of this subject while studying in this semester is to understand different methods used for simplification of Boolean functions. Second point is to design and implement combinational circuits. As we know that there are different circuits like combinational, sequential, so all these we are going to see in this syllabus. And the third point is to design and implement synchronous and asynchronous sequential circuits. It means the sequential circuits which are of two types, synchronous and asynchronous. We will see this in detail. So we should know how to design these circuits and how to implement all these circuits. And the last point is to understand working of convergence circuits. Okay, so this is our objective. It means at the end of this syllabus, we all should be knowing all these concepts. Let's come to the next slide. Here we can see the syllabus of this subject. The first section, which consists of 3 units. Here we are going to see 2 units in detail. So first unit is number system. In this we are going to see different number systems. For this chapter we have to study or we have to spend 6 hours. Means it is expected to cover the first system in first unit in 6 hours. The second unit is introduction to analog and digital signals, which is of 6 hours. The third unit is Boolean logic, which is of 8 hours. And now the section B, the unit number 4 of section B, which is data processing circuits, which is of 6 hours. Unit number 5, clocks, 6 hours. And unit number 6, registers, 8 hours. Okay, so going back to the first unit. The first unit, the syllabus which is covered is the binary number system, sign binary number systems, binary arithmetic, decimal number system, hexadecimal number system, octal number system, arithmetic operations using 1's complement, 2's complement, 9's complement, 10's complement, etc. And the codes, that is numeric codes, weighted codes, not weighted codes, sequential codes, self-complementing codes, cyclic codes, reflective codes, BCD codes, XS3 codes, and the gray code. Okay, so from this we can see as we have to study all the number systems, means the binary, decimal, hexadecimal, all these number systems are classified according to their base. Okay, the base is also called as the radix. All these we will see in detail. I am just giving you the basic idea of what is the number system. For an example, if the binary number system we are going to study, it is having the base 2. It means we know that the binary number system which is indicated in the form of zeros and ones. Okay, so 0 and 1, therefore the base for this binary number system is 2. Now coming to the second unit. In this we are going to see the introduction to analog and digital signals. In this chapter we are going to see the introduction of analog and digital signals. So we know that analog and digital signals, which we are going to study on the basis of their characteristics, like analog and digital, the parameters of that signals are in the form of analog, either it is in the digital signals. We know that in the previous instruments of digital electronics, many of a time we were using the analog signals, but as the technology is getting advanced, many systems are converted into the digital form. So we should know what is the difference between all these analog and digital signals. So this we will study in the second chapter. Then the next point is logic gates and switching functions. Different logic gates like AND gate, OR gate, NOR gate, derived gates. These different gates we are going to study. Okay, and XOR gate, XNOR gate, universal gate, NAND gate, NOR gate. Then the introduction to logic family, RTL, ECL, TTL, CMOS, characteristics of TTL, CMOS. It means we are going to see the detailed characteristics of TTL and CMOS. Then we will see the representation of equation using logic gates. These are the first two units. Then the unit number 3, which is very important, in which the syllabus covered is Boolean algebra rules, De Morgan's theorem, Boolean algebra, representation of logic functions using standard POS SOP form, minimization logic functions using Karnaugh map, which is also called as the K map. So in this is actually a very interesting chapter, and you will have fun while solving all these concepts like POS, SOP, and the K map. Then the essentials of logic equations using logic gates, combinational circuit designing, which are the combinational circuits like half and full adder, half and full subtractor, adder with look ahead carry, BCD to 7 segment decoder, then binary to gray code converter, gray to binary code converter. This is actually completely a calculative chapter in which we have to learn various techniques to solve the algebra, Boolean algebra. So this is about the first section. Now coming to the section B. In the second section, the unit number 4, that is data processing circuits of 6 hours. What are the data processing circuits? In this we have to see the multiplexers, demultiplexers, decoders, encoders, exclusive OR gates, means XOR gates, parity generators, checkers, magnitude comparator, and the next point is introduction to PLD, realization of logic equation using data processing circuits. So all these data processing circuits we are going to see, means how to design these circuits, and using this multiplexers and multiplexers, how we can design a advanced circuit. All this we are going to see in the 4th chapter. Now coming to the unit number 5, that is clocks. Here we are going to see and learn different types of clocks, and in this clocks what are the different waveforms that are generated. Means the first point is clock waveform, TTL clock, squint trigger, flip-flops, introduction to sequential logic circuits, 1-bit memory cell, flip-flops. In this we are going to learn different types of flip-flops like SR, JK, D, T flip-flop, the clocked D flip-flop, age-triggered D flip-flops, age-triggered JK flip-flop, flip-flop timing, JK master-slave flip-flop, then flip-flop conversion. As this is our first lecture, you might get confused in all these terms because you are not that much familiar to all these terms. But as we will study deeper in this subject, you will get very familiar to all these topics, and when you will solve and design all these circuits, you will feel like all the concepts are very easy. So the last point is JK master slave flip-flop conversions. Okay, means in this we are going to see different clocks and all the flip-flops, study all the flip-flops and also the conversion of one flip-flop to another. And the last unit of the section B is registers. Here we are going to see different types of registers: serial in, serial out, that is SISO register, SIPO, and parallel in, serial out, that is PISO, then parallel in, parallel out, then universal shift register, applications of shift register, counters, introduction to counters, types of counters, application of counters, designing of asynchronous and synchronous counters. So all the registers and counters and different type of SIPO, all these are studied in the registers chapters. Okay, so this is all about the syllabus. We will start the first chapter in the next lecture, but before end of this video lecture, we will see the basic concept that we are going to study in the first unit, that is the number system. Okay, I know that all these basic concepts you have studied in the previous subjects of the last semester, but whatever there is new to you, we will see. The number system is used for representing the information. Okay, we know that what is a number. Number actually itself says that it is used for counting purpose. So wherever there is any information and we need to represent it in a systematical form, there is a need of number system. The number system has different bases, and the most common of them are the decimal, binary, octal and hexadecimal. Now, why the number systems are classified in all these forms: decimal, binary, octal and hexadecimal? All these number systems have a particular base or radix. So where there is a decimal number system, it is from 0, means the decimal number system consists of 0 to 9. It means the base of this system is 0 to 9, that is 10. So the same point is explained here. The base or radix of the number system is the total number of the digit used in the number system. Suppose if the number system representing the digit form 0 to 9, then the base of the system is 10. For an example, decimal number system. So this is the basic concept of number system. Coming to the next slide, here we can see the different types of number system. Some of the important types of number systems are: number 1, decimal number system; number 2, binary number system; number 3, signed binary number system; number 4, octal number system; number 5, hexadecimal number system. In the next slide, we can see the different decimal systems and the base of these number systems. Here we have shown 4 types of number systems: decimal, binary, octal and hexadecimal. So decimal number system, we know that it uses the digits from 0 to 9. Therefore, the base of this decimal number system is 10. Binary number system, which is expressed in the form of zeros and ones only. Therefore, the base of this number system is 2. Octal number system, as the name itself says that it is from 0 to 7, means octal means 8. So from this we can learn the concept and fix the concept in your mind that from the name itself, octal means 8. So numbers used are from 0 to 7. And the last number system is hexadecimal. Hexadecimal, from the name itself, hex, that is 16. Now, how the 16 numbers we can use? Not actually the numbers. Here we are using the digits from 0 to 9. Means from 0 to 9 we can use all the combinations of these numbers and the alphabets from A to F. So using all these numbers and alphabets, the number is designed and which is called as the hexadecimal number system. So this is the basic concept of number system. In the next lecture we will start with the new chapter. So thank you and see you in the next lecture.